Sorry about that. Now the audio should be working. We've got a single constructor here where we take each one of those pieces of data. I demonstrated how you may or may not want to validate the data. For example, it's bad data if there is no book title. And so we end up throwing a runtime exception where you can't create a book without a title, right? Otherwise, we set each one of those things. Remember the keyword this is how you can refer, an object can refer to itself. So it's me, myself, and I, but it's for an object which is not a person, so this, right? And then we had a toString method here that output the book in a well-formatted manner. All of that stuff is in the book class because it deals and pertains to books, right? I don't put it over here in the demo class because book stuff belongs in the book stuff. Main stuff belongs in the main class. Arguably, this comparator, this load book data, that may belong into another book, into the book class or a book utility class or something like that. We'll talk about object-oriented programming principles here coming up as we transition into object-oriented programming. But one of those principles is going to be the single responsibility principle. One class should be responsible for one thing. Right? Now, what that thing is kind of a gray area. But there are certainly things that do not belong in other classes. For example, if I had like a bank account class, right? Should I put that data into the book class? Clearly not, right? Books are not bank accounts and bank accounts are not books. So we want to make sure that we separate our responsibilities into the various classes. We could reorganize this code and we could put this load book data into a book utilities class or something. We could take these comparators and put them into a book utility class or something. We could then, the reports that we're about to run here, we could put that into another utility class or something. Just separation, right? Just like you don't want one function that does everything. You don't put everything into main, right? You separate things out into different functions. Now that we've got classes, you separate things out into different classes as well, okay? Otherwise, we left it off here by creating a couple of comparators that order books by rating, right? I forget top to bottom. I think it was best first, and so we reversed it. And then by author. And we use this modern syntax here of comparator dot comparing. And then we defined what kind of a function or what method do you want to use to compare them. And in this case, I'm using this colon colon. That is the function or method selection operator. It comes actually from C++, I believe, where you define a book or my class, and then this is a function in the class. You use this dot dot syntax. Anyway, we start comparing by the author's last name. Dot, then comparing a book by the author's first name. Dot, then comparing a book by the release year. Okay? We demonstrated how to sort this using those comparators. Let's go ahead and run this again. And we see up at the top here, we have a book by Oral Jean, then Gibson, then Heinlein. All the way down here at the last, we've got Rowling. Right? So it has been sorted by author. Now we can finally do those reports that we were shooting for. Let's find the worst book. Let's find the best book. Right? Well, if I'm going to find the worst and the best, and I've already got a comparator that orders them by rating, let's go ahead and do that. I will go ahead and sort them by not author, but by rating. Right? Let's verify that that's actually sorting in descending order according to the rating, and we see here that it is. Right? Here's the top, where's the best book here? The best book is going to be where? Apparently up here. The best according to the Goodreads ratings, right? These are not my ratings, but 4.62. Right? Generally, with Goodreads, best translates to most popular. Right? And then the worst here is going to be Dianetics. Right? So I don't have to print those all out. If I've already sorted them, all I have to do is get the first one. Right? Here's the worst book. So book, worst book is equal to, where's that going to be? It's going to be at the very last, after I've sorted it. Library dot get the last one. 0 would be the first one. What would be the last one? Library dot size. Careful. What if there were 5 books? The size is 5. If it's 0 indexing, where's the last book going to be? 0, 1, 2, 3, 4. So -1, just like arrays. And the best book is going to be right at the top, library.get 0. Right? Or best book. And let's go ahead and print those out to make sure that we're getting those values. Dot print ln. I'm going to go ahead and print a divider here. End line, there we go. So that we can actually see that these are the best and the worst book. And remember, I can do this by putting this into println or print or printf or whatever. Why? Because I overrode the toString method. This is where all that logic for actually printing it out as title by author last name, comma, author first name, year, and then in parentheses there. Just to show you that it works like that, I'll go ahead and only go out to 2 decimals of accuracy here. Right? And now let's see what the best and the worst are. Oops, I didn't save. Did I save?
You overwrote the divider.
Oh, say what? Oh, did I? Oh, okay.
Yeah.
Darn it. I'll put that back in. End line. There we go. Sorry. All right. Dianetics, worst, and best is going to be that Rowling book. Okay. Now let's find a book. All right. So you can, of course, do a linear search. Find a book where the titles or where the author is equal to author's last name is equal to Herbert and the first name is equal to Frank. Right? Are we just interested in one? Are we interested in all? I don't know. But remember that there were 2 kinds of sorts, or 2 kinds of searches that we covered in Computer Science 1. One is linear, where you just start at the beginning. Is this it? Is this it? Is this it? No, 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 until you get finally a yes. There's my first book. It would look something like this, right? For book B in the collection library. Right? What I'm going to do is I'm going to ask if B dot get author's first name is equal. Oh, by the way, should I be doing this? Equals Frank. Right? And B dot get author last name is equals Herbert. Right? And get rid of that. There we go. Then I found my needle in the haystack. Is that how we do string comparisons in any language that we've covered up to this point, C, Java? No. In C, we would use strcmp. What is this doing? It's comparing the memory address of that string and that string, not the contents. So to actually compare the string contents, you need to use dot equals. So if that string equals, the contents equals Frank, and if that string for the last name is equal to Herbert, then I found the book that I'm looking for, system.out.println B. Let's run this. This is a loop that's going to run over all the books. So it's going to print out all of Frank's books, right? All of them, instead of just the first one. It seems like that this is such a common task. Maybe it's built into the language, right? And so let's go ahead and check it out, right? So a library.contains object, or better yet, library dot, I want just the first one, dot index of the best book, or so what's the index of the best book? Let's go ahead and capture that value, int x is equal to, and let's system.out.println x. There we go. 0. The best book is right at the beginning. I'm not looking for the best book, though, am I? I am looking for Frank's books. How do I do that? Yeah, so how am I going to specify that when this requires a book, right? I want you to give me the index of this book. Right? Now, in C, what we did is we created a dummy key, right? So book, Frank, a Frank book, right, is equal to new book. And, well, I don't want a title here, so I'll just go ahead and go null. But at this point, I'm going to have to take out that validation there. So maybe I do have now a use case where I do want a title that is missing, because I want to use it as a dummy key in my code, so I can search for things that match Frank, Herbert, but not the rest of it. Okay? So null, what else was in that? Let's see, Frank, Herbert, and then I don't know what release year it is, so Frank, Herbert, and then 0 for the release year, just a dummy value here, and then finally, what was it, 0.0? There we go. Right. Except that I had to provide a lot of, so now let's see if this is not going to actually work yet. But before we get there, I want to point out that, wait a second, just to create this book, I had to have a bunch of null values, 0 values, default values. I now have a case where I want to create a book with just the author, okay? So let's come back over here to the book class, and could we do that? Could we have another constructor that didn't just take all 5 pieces of data, it just took those 2 pieces of data that I'm interested in, and then set defaults for the rest of it? And yes, you could type it out if you want to, or you could go ahead and construct it using the auto-generated code here. So let's go ahead and deselect all, and just select author's first name and last name, generate that, and there. Now I can use that constructor over here, not having to deal with those default values. Oops. Frank, Herbert. Much cleaner code, right? It should be. I didn't save it over here, that's why. Right? Much cleaner code, right? Now I'm not crufting it up and cluttering it up with a bunch of default values. And it's all because I had the desire for another constructor. All right, go ahead, write another constructor. Right? Yeah?
Since you wrote that new constructor, could you keep that like check for a null title in the other constructor?
You could, yeah. So you don't give me one, fine, but if you explicitly give me a title, then it better be valid. Yeah, I like that. Let's go ahead and run this and see that it actually works. Right? Well, the construction works. This does not work, a Frank book. So now think about what you're doing here. By default, have you defined that, a way to say that this book is equal to that book? No, right? So one way that you could do this is, well, okay, I've got this book that only has Frank and Herbert defined. I want you to go through and find any book whose author matches that thing. That sounds mysteriously like a comparator to me, right? Except that instead of including the release year and the author's, the release year in this ordering, I just want the last name and the first name. Why are you griping now? Did I change something? Okay. Oh, probably this goes away. All right, there we go. That is really weird. Eclipse has been acting up lately for me. Like if there's one syntax error somewhere and something completely unrelated happens, and I have no idea why. But anyway, so the point here is that I want a way to compare this book to that book, but just based on the first author, the author's first name and the author's last name. So let's do that. Let's go ahead and rename this by author, then rating, and then let's steal that code and make a pure comparator that is just by author, ignoring this last ordering here, by author. Okay? Now, can we use that in index of? I want you to use that comparator instead, and no, we can't. Instead, what this is doing is it's requiring you to use, it's an old method from Java like 1.1 or 1.2 or something that is not going to allow you to have a comparator. There is another way of doing this though. I think it's collections.find, nope, linear search, nope, index of, last index of singleton, no, darn it, what is it? Library dot, there should be one that takes a comparator as well. Index of, using a comparator, darn it, I don't remember it off the top of my head. So when we forget something off the top of our head, that's why Google exists, or DuckDuckGo at least. So Java, list, find, or search, with comparator. Search array list using a comparator. Hopefully they don't come up with a binary search, because that's ultimately going to be our solution, but darn it. Okay. Doesn't look like there's one built in, because if you're going to be using a if you're going to be using a comparator anyway, they're wanting you to use something better. What's that something better? Not a linear search, but a binary search. So let's go ahead and sort it using that new comparator that we just created up here, collections.sort, right? And collections.sort, excuse me, my library, but using the by author comparator. And now I can go ahead and use collections.binary search library using the same one, by author. There we go. What are you complaining about? Okay, index binary search. I don't think that that's correct, but, oh, wait, sorry, no. What do we need? We need the needle, we need the haystack, and then we need the comparator. So what is our haystack? The thing that we're searching through, library. We need our key, the thing that we're searching for. I think it's a Frank book, by author. There we go. Just to make sure here. The list, then the key, then the comparator. And now this should find a Frank Herbert book. It's going to be at index 9. If I got that element, right, book, a Frank book, right, is equal to a, what would it be, library dot get the one at that index x, and then print that out, system.out.println x, an actual Frank book. There we go. Which one did it find? Looks like it found God Emperor of Dune by Herbert Frank. The last one in the list of all of them, right? That's just because of how binary search works, right? Now I want to do an exercise where I don't just find one Frank Herbert book, I want all of them, right? To do that, in fact, what I want is, I want a way to organize all the books. I want to take all of Frank Herbert's books and put them into one pile. I want to take all of J.K. Rowling's books and put them into another pile. I want to take this author's books and put them in the pile. It could be that that author only has one book, right? So, ideas on how to do that. Okay, oh, a list of what? A list of books. I already have that.
List of indexes.
Okay, oh, okay, so here's Frank's books, and all of his indices are 9, 8, 7, 6, 5, 4 in the sorted one, right? Why store indices when you've got objects now in an object-oriented programming language, right? The index would say, okay, well, if you look up that index, here's the book. Why not just take the book, right? So a list of books, but now we're back to square one, right? So remember that a smart data structures and dumb code are a lot better than the other way around. What if I had something where I had, say, last name maps to a set of books, something like this, so that I could have, say, Herbert maps to a set, oops, and I don't know if you've had discrete math yet, but a set is denoted using curly brackets here in mathematics, not necessarily in code. But then I have all of these books in this list up here. Something conceptually that looks like this. Of course, this is not Java, right? But an idea like this, okay? What would I be looking at? What kind of a data structure would I be using here? A dictionary. In Python, they call them dictionaries. They're even more powerful in Java because a dictionary in Python maps either integers or strings to whatever. But here we've got something even more general, a map, where you can map arbitrary things to arbitrary things. You are not just limited to integers and strings over here. A map. What if we mapped an author to a set of books? Right? So by author. I've already got that, so I don't know. Library by author. Right? It would look something like this, where we map an author to a set of books. Let's get rid of this so that it actually compiles and we can actually make sense of this. Right? Now, first of all, we know what a book is. let's go ahead and import set, import map first, and then set. There we go. All right. The only thing that we don't have is an author. Why don't we have an author? Because our design was deficient to begin with. Right? When you're talking about encapsulation, the way that you design an object or a structure or something like that is anytime you have more than one piece of data that conceptualizes one thing, you should be encapsulating that into something. So a book is a title, an author, first name, last name, a release year, a rating. Right? So what about these two pieces of data? Right? Should they be separate? Probably not. I should be wrapping those up into another conceptual object called a person. We could do that, and just in fact, generally I would, right? Let's just go ahead and make it into a person. They have a role that's an author on one book, but this class could be useful if you've got, like, say, a customer or a bank account owner, right? Or a bank account manager, right? Whatever. A person is a person. Not all people are authors, and not all, all authors are people, despite the AI, right?
What were you trying to say there?
Not all persons are authors, but all authors are persons, right? But now with, crappy AI writing crappy stories, now maybe we have to rethink that, right? Anyway, let's say, let's go back over here to book, right? I'm going to take those two things, I'm going to move them over to the person class here. So I'm just going to go ahead and make it immediately private, string, last name, private, string, private, string, first name. Correct. Right. And now that I've seen how to properly, generate code, I'm just going to go on a speed run here and generate a constructor using fields. I'm going to generate a bunch of getters and setters. Just not setters, but I'll select all the getters, generate that, right? And I'm nearly 100% done with my class here, okay? By the way, when you start writing your own classes, the class deserves documentation. This one is pretty simple and it's straightforward. A class that represents a person, right? Conceptually, that's all you really need. But what about this function, which is a constructor? What about these functions that are called getters? They don't need documentation, right? They're self-documenting. So yes, the class needs documentation, but these functions here don't need documentation, okay? Yeah?
Is there, I guess, why would you create like a string last name, string first name as private and then have functions to grab them instead of just making them public and accessing them directly?
Because encapsulation is the grouping of data, we've got that, the protection of that data, private. Just like with the book, I don't want you to allow you to create a book initially without a title. Maybe a reason here would be that everybody has to have a last name, or everybody has to have an NUID and it has to be valid at 8 digits or whatever, right? And not negative, right? So it allows you to do data validation, but the biggest answer is something that we unfortunately generally don't cover in first year CS, CE, whatever, is parallel programming, right? We are no longer in a world of single processor units, right? Every processor, even on a simple phone nowadays, is going to have multiple cores, right? And so thread safety is vital, or thinking at least in parallel is vital. If you've got in fact, I'll add on to this, private final, right? We'll talk about that here in a moment. But this makes sure that this person class is immutable, just like a string. And with that, you have thread safety for free, right? Don't go against this pattern unless you have a very good reason to do so. Right? We'll take a look at an example later on where we have a good reason to do so, but then we'll come up with another pattern that satisfies that reason without having to sacrifice strong encapsulation like this. Right? This is just data, right? So what I've done here is I've put the final keyword on this. So in C, you have the const keyword. Once you created something, you cannot change it. Final is the equivalent in Java. If I tried to, say, set the last name and then go this.lastName is equal to foo, this is going to be a compiler error because it was final, you set it once, no, you cannot reset it ever again. All right? Now, let's refactor this book class so that it does not have a separate author first name, last name. Instead, it just has a person who is an author. There. That's proper modeling. Right? That if I separated out the first name and last name, I'm not treating that with real encapsulation because I'm not modeling the problem correctly. Right? Now let's come down here, and instead of these getters, it'll be get author, return this dot author. There. What are you complaining about? Oh, and then the return type has to be author. There we go. Oh, thank you. There we go. It's a person. It's a person. Right? We'll go ahead and change this so that it takes a person, which is the author. And now we can start conceptualizing, here's a book, here's a person, here's an, that's an author, et cetera, right? And change this one so that it's an author. Except that now that it's one thing, right, is there a better way of doing this? I don't know if that person, that book was written by that author. Those three other pieces of data are now irrelevant. All I want to know is that book's author equal to this author over here? That takes me back to the person class here. How do we tell that two people are the same? If their last name is, last names are the same and their first names are the same. Right? Do you remember how to do this? Right? Just some quick code here. Last name dot equals, right? That last name, right? That's a string. This would be a string, and then this would be a string. And it's going to be, yes, that thing is equal to that thing if this dot equals says it's so. True or false? Where do you think that is? Right? That's in the string class. Let's take a look at what it looks like. Find equals. Right? Equals, there we go. First of all, it checks to see, is that object the same thing as this object? Because if they're the same thing in memory, they're definitely the same. True. Otherwise, well, is that object actually a string? Right? Is it a string? Is it an instance of string? Then yes. If not, then it returns false. Right? Otherwise, and is the then it goes into some complex. It calls another function here that actually goes character by character by character, saying that thing is equal to that thing. This is just like strcmp right here. Every object is going to have that an opportunity to do that. Right? I can write my own equals function. Public Boolean equals. Right? And what it takes is another object. Oh, that book. Or that author, a person, I should say. Right? And then that person is equal to this person, whatever. Again, do you want to type this out? No. So once again, we will use the magic of the IDE. Source, generate hash code and equals. These two are always together, they're married. Do not define one without defining the other. Let's just go ahead and generate it and see what it looks like. Right? There. So if that object is equal to this object, then certainly they're the same thing in memory, they're equal. If that object is null, then this object certainly is not, otherwise we wouldn't be here. So false. Otherwise, if the classes are not the same, that one is in person and that one is a book, right? They can't be equal. Otherwise, we'll transform this object into a person because we know that it's safe. And then we start asking questions. Are the first names the same? And are the last names the same? All that complex logic, did I have to rack my head against the wall to remember every single possible case, every single possible thing that could go wrong, et cetera, et cetera, et cetera? No. I just let the code generate it for me. And now I can make a check. Instead of having, is this book equal to that book based on the first name and the last name, all I have to do is say, is that book's author equal to this book's author based on the equals method in the author class? Good encapsulation. I've grouped the functionality that, that acts on that data inside the class. This kind of thing, the equals method here, what if I'd taken that equals method and put it somewhere else, right? Like strcmp is, right? Where all the person stuff is over here, all the person data is over here, but all the person behavior functionality is over here, right? Why would you separate those? Encapsulation, bring them all together into one class, okay? Now let's finish up over here. This dot author is equal to author. That takes care of most of this stuff except for this. Oh, I always wanted to print it out last name comma first name. So this dot author, right? I'll print that out as one string. Where should the responsibility of formatting an author as last name comma space first name be? Should it belong in the book class? No. Why? Because it's doing an author thing. Author things, or person thing, I guess. Persons, it should belong in this class. Right? Again, source, generate toString, and it's going to generate something that looks like this. That's not what I want. String.format, %s, comma, %s, and then last name, comma, first name. There. Again, auto-generated code is not the best. Right. Wonderful. Now it takes care of the formatting where it belongs. Right? I have separated book and author concepts into two different classes entirely, including the behavior of determining are these two things equal or not? Are these two things, how do I convert this to a string for human readability, et cetera, et cetera. Everything's fine over here. Now we have to refactor over here, everything over here in the demo class, unfortunately. All right, there we go. So book, new book, and this is not going to be last name, first name. Instead, I need to make a new author. So person, author, is equal to new person. And it was first name, last name? I forget. That's okay. We can go ahead and go over here. Last name, first name, excuse me. Right. Last name, first name. And that's a shortcoming actually there where you've got string, 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 string. If you've got a very long constructor where that takes 5 strings, what was the order again? Right? There are better patterns of dealing with that called a builder pattern that we may or may not explore later on. Right? Anyway, now I can build it with the author. Excellent. How does this change right here? Can I get the author's last name anymore? Nope. I can get the author though. I can't get their first name either. Well, what's the problem there? Right. Comparing. This method comparing in the type comparator is not applicable for the arguments book author. What was it before? It was a string, right? That's built into the language. Strings are comparable. This string and this string, it knows how to compare those two things. Now, how did it achieve that? Right? Let's go over here to the person class, and I'll show you. Implements comparable, right, of person. There we go. We'll talk about the syntax later on, but basically what this is saying is that this person is orderable. This person comes before this person, or this person comes after this person, or this is the same person based on the equals method or something, right? I'm saying that this thing is comparable to a person, this person class. If you gave me another person, I could compare those people and say that Herbert or Gene Arl comes before Frank Herbert because last name, first name order. That logic can be implemented directly in the class here, compare to, right? Given that other person, them, right? Me and them, or that person, right? This is where I put that logic. I return something negative, positive, or 0, depending on the relative ordering of those things. So let's do that. Int result is equal to this dot first name, or last name. We'll do last names first. Dot compare to that dot last name. So I'm not returning anything yet. This follows the same pattern. compare to. What does that tell you about strings? Strings are comparable to other strings. That's how this is working. Compare to is going to return something negative, positive, or zero, depending on the relative ordering of this stuff. Right? Now, if they have the same last name, what should we do? If result is equal to 0, right? Herbert, Herbert. There's no way to determine if it's this Frank Herbert or is it his son, Brian Herbert, right? So what do? We go to the first name. Result is equal to this dot first name dot compare to that dot last name, right? Return the result. And at that point, we're done, right? If they have the same first name, the same last name, then there's nothing else we can do, right? They're the same person. If you wanted to, you could bring in like a social security number. And now everybody is uniquely identifiable. Yeah. Any question?
Oh, me?
Yeah.
Are you supposed to do the first names?
Oops, sorry. That was just autocomplete. That would have been really, really difficult to find too, right? All right, there. So now come back over here to the demo, and guess what? That syntax, or that compiler error now goes away. Why? Because if I gave you the author of this book and I gave you the author of this book, all it has to do is go into that class and say, oh, it has a compare to method. The logic is there, I can find it. Right? This person comes before this person. Right? And then get the release year. Same thing down here. It's just a cut and paste. There we go. And then I don't have to compare the first name because that's no longer part of the book class. Already I'm simplifying code. Why? Because I'm taking the heavy lifting and I'm moving it off into the class where it belongs. Right? All right, what else do we need to change? I can no longer create this new book, but I can create an author. Right? An author, A is equal to new person, or person. Author, Frank. I'll just call him Frank because that's who he is. There we go. It was last name, first name, right? There. I'll go ahead and get rid of this entirely because we are using binary search down here. Okay. So now I've got a person by author, right? Not a Frank book, but, oh, I guess I should wrap that up in a book, right? Book, a Frank book is equal to new book, given that Frank author. There we go. And this should work now. Let me go ahead and get rid of this and actually test. This is called regression testing. Not really because it's not a formal test suite, but basically if you've got a bunch of tests and then you go and you do a redesign or recode or refactoring or fix a bug, you want to make sure that that it didn't regress, that you didn't take a step backwards. And so let's make sure that we didn't take a step backwards here by verifying that everything ran. It doesn't. Comparable because what is null? Oh, wow, okay. So where did that happen? Arrays.sort, blah, blah, blah. It happened on this line. By author, library we had, sort by author should have been this, comparing author. We had a null author. Oh, hopefully we were setting it right. Oh, I just erased code that actually set the author. So this is a good opportunity. I don't want to fix this right away. I know what the bug is, but I don't want to fix this right away. What I want to do is I want to debug this. All right, so let's go ahead and debug this and switch to our perspective over here, okay? What's going to happen is we're going to have I don't want that as a breakpoint there. What was the, let's just run it pure here. Null pointer exception, right? Actually, that's where the null pointer exception happened. Breakpoints. Let's go ahead and add a breakpoint. So you can go normally, you can go line by line by line. I want a breakpoint here, I want a breakpoint there. Or you can go ahead and go up to this button right here. It says J and an exclamation point. This is add Java exception breakpoint. If ever a null pointer exception happens, what you can do, null pointer exception, is set a breakpoint. It's not at a particular line, it's under a particular condition. If anybody ever throws a null pointer exception, what we can do is we can stop at that point and then examine everything. That's what it was doing by default without me setting this. So let's go ahead and debug this. There we go. We ended up here. Unfortunately, what is C1? What is whatever it is? Okay, there we go. These are the actual books. Harry Potter and the Deathly Hallows by Noel. Name of the Wind by Noel, right? And so I kind of see the error here. None of my books are getting their authors. That tells me that I need to go back to the book code here, the constructor, where it actually gets set. This dot author is equal to the given author. There. Stop this, run it again, and there, now it works. So conditional break, I'm glad I took that opportunity to show you conditional breakpoints. Breakpoints over here, if you have like say a number format exception, right? There we go. It'll stop on any number format exception at that point. It's not a particular line, it's just wherever this exception occurs, it'll stop execution so you can take a look around, right? Let's go back over here to the Java perspective and get rid of this. There we go. All right. So we're good up to this point. Now let's go back to the original problem here. I want to organize all my books into different collections. All of Frank's books, all of Rowling's books, etc. Right? To do that, I'm going to create a map of my library by author. And oops, not author, but person. There we go. So that for each person in my library collection here, that's going to be a key, right? This is a key. Person is a key that maps to a set of books, which is a value, right? Key value pairs. Ideas on how to do this. Well, how would you do this in an actual library? If I just gave you these 20 books, how would you organize them into bins that represented the authors? Take the first book, right? And okay, this author is Jean Aural. All right, do we have a bucket for her already? No? We need to create one, and then I'll put it in there. Right? Next book, same author. Oh, okay, I need to find the bucket for her books and put them in there. Right? Next author, have we seen this author before? If so, we need to find the bucket that we put it in and put it in there. Otherwise, if this is the first time we've seen it, what do we need to do? We need to create a new bucket. We need to create a new set, put that in there, and then associate it with that person. So let's outline this. For each book, right, find the bin, or which is the set of books, for that author, for that book's author, right? Add it to the bin, or so if no such bin, create one, right? Otherwise, else, add the book to the bin, right? There's my outline. This is exactly what you would do in real life, right? I mean, it's pretty straightforward. All we need to do is think, that's problem solving. The problem is solved. But now the hard part is translating this into a piece of code that a dumb machine will understand. Right? But we do have smart data structure, this map right here. We need to initialize it, new hash map. There we go. And need to bring that in as well. This convenience, this elision, E-L-I-D-E, E-L-L-I-D-E? I think it's just one L, I'm not sure. But in any case, this is elision, right? You don't have to repeat yourself. You don't have to repeat that this is a map from a person to a set of books. Right? It is just what it is. I can figure that out, says Java compiler. Right? All right, so for each book, for book B in the collection library. Right? Find the bin, the set of books for that author. Because we're using a smart data structure, a set of books, or author's books, right, is equal to library by author dot get that person, b dot get author. Right? So now again, let's read this. Here is my map, right? I want you to get the set of books by this author right here, by B's author. Right? Now, if that does not exist in the map, it will be null. So if no such bin, if author's books is null, then I need to create one. So I need to create authors, books is equal to new hash set. There. Of, come on, what are you complaining about? I imported you up there. Oh no, I imported the hash map, sorry. Okay, I got confused. All right. I just needed to import it. There, create one. And then add it to it. Now, this is not really an else statement. It's just add the book to it, to the bin. Right? Up here what I'll do is, I'll save it. We'll do this later. Let's go ahead and add it. Authors, books, dot add. How do I add a book? B. So there's the set. If it didn't exist, I created it. Now I know that it exists because either it existed before or I just created it right here, and so I can add that book. Right? Now what you have to be careful about is how do you get these things into the map to begin with? So if this is the first time you've seen it, right? So this is the first time we've seen this author. So create their bin, right? And then place the bin in the map. We never put anything into the map, right? Library by author dot put. Not Frank, but b dot get author will map them to the author's books. Right? All magic, right? All I'm doing is organizing this. This book goes in that bin, that book goes in that bin, that book goes into that bin. Right? Smart data structures. Smart data structures and dumb code are a lot better than the other way around. All right? Run this. It ran, but we don't see the effect here. Let's go ahead and go with system.out.println. It's not going to be pretty. Not author's book, but library by author. Right. I'm teaching Python in one of the other courses, and they've got this library called pprint. The first P stands for pretty. So it's got this library that you can give it anything and it'll print it in a nice human readable format. This ain't gonna be so nice. Right? There's Gibson, William. He's mapping to the single book that he has, Neuromancer, comma. Terry Pratchett is mapping to Color of Magic, Raising Steam, and Mort. They're his 3 books. Oh, and Weird Sisters. Jean Orrell is mapping to her one and only book in my collection, right? Herman Melville to Moby Dick, et cetera, et cetera. Where is that? Again, it's not going to be pretty. There's Patrick Rothfuss, both A Wise Man's Fear and Name of the Wind, J.K. Rowling, Frank Herbert, there he is. God Emperor of Dune, Dune, Messiah, Heretics of Dune, Dune, and Children of Dune, and finally Chapter House Dune. Right? Isn't that awesome? I mean, data manipulation like this using smart data structures, super, super easy. In fact, one of the classic assignments that I give is not for like their first assignment, is to create a report, not based on this by books, but by video games. So you've got a video game title, their publisher, and then the platform that it was published on. But it can be published on multiple platforms, right? And one publisher can have multiple games. So I don't, like Nintendo. Nintendo has like 5 games, right? But they're all published on one system or something. But whereas like a AAA title like, I don't know, Halo, is published by one publisher, but it's available on PC, Xbox, PS5 at this point, right? Whatever, right? And so in that we give a flat file like we did here. Here's our flat file, our books file. And you have to process it and you have to come up with reports of how many books, in this case, how many books does each author have? It's trivial now. Library by author. Let's make that report. How many books does each author have? Right. If I just went with this CSV file right here, right, and like I would have programmed this in C, right, using a bunch of nested loops over and over and over again. Huge mess. But over here, if I have a smart data structure where I map an author to all of their books, how could we do that? For, and here's how you iterate over a map. I'm also doing it to demonstrate how to iterate over a map. For author, or not author, but person, which I'll call author, in library by author dot key set. Right? So for each key in that map, right? System.out.println .printf %s has %d books. End the line. So the author, and then we're going to get the author's books, set of books. I'll do it in a separate line here. Books is equal to library by author dot get all of their books, author, and I'll simply just take the size of that set of books. There. Let's run this and see what we get. There we go. William Gibson has 1 book. Right. There's Frank Herbert, he has 6 books. Right. Did I miss one? Were there 6 books?
Yeah.
There were? Okay. All right. So, yeah, I'm not crazy. I just forgot that there were 6 books instead of 5. Right. And then there are more by Brian, but whatever. Right. So how much easier is this if you use a smart data structure? Right. Another thing that we generally require is we want you to give this report in order of author's last name, first name. Okay. All we have to do now, because we have proper object-oriented design, we've made sure that everything is comparable, et cetera, all we have to do is take this key set and dump it to a list and sort the list, right? So list of person, authors is equal to new array list. And what I'll do is that's what's called a copy constructor. I will take all of the authors in the key set of my map, put it into a list, and now I can go collections.sort authors. Note here, I did not need to use a comparator. Why? Because I did this work up here. It's already comparable. Right? Really cool. Right? And now I just have to sort it. And now I can go ahead and iterate over not the original list, or set, but this list that has now been sorted. Let's run this again and see that who's the first one listed? Arl, Gibson, Heinlein, Herbert, all the way down to Rowling. Right? So as long as you start at the bottom and start designing your classes first and realizing, okay, I've got an author, I'm probably going to want to sort that author and compare that author to that author. And as long as you've got this object implemented correctly, first and foremost, then use that as a building block for another object, use that as a building block for another object. It all becomes really, really simple, right? It's basically, I like to describe it as long as you set up all the dominoes correctly, all it takes is for you to knock the first one down and the rest of them fall, right? That's the bottom-up problem solving. Remember on day 1 I talked about computer science 1 is starting from the top and breaking it down into smaller and smaller bits until you're there, right? We kind of did that here, but that's because that's what where we started. This actually, if I were to do this from scratch, I would have started with a person because I knew that I'm going to have to model an author. Then I would have gone onto the book and built that. I would have gone bottom up instead. Designing the things that model the problem and then bringing all those things together using smart data structures to get some really powerful reports here. Right. All right, questions on that so far? No? Then let's pull back a little bit and do a simple exercise. Hopefully you've got maybe the first 2 problems done on your assignments. Yes? No? All right. I'm not doing the, occasionally I'll bring up that Gantt chart, but just to get you some more practice here, I pulled out my Computer Science 1 textbook, and here's this is from the loops chapter, I think. Here's a nice little exercise to get some more practice doing Java. I want to approach this first coming from the mindset of Computer Science 1, where we're just going to go, it's called a structured or procedural style, where you're going to do everything like you would do in C. Right? We'll do that as a first attempt here. So let's read this. If you've got a radioactive isotope, right, you've got some plutonium or you've got some uranium or something, then, and it's radioactive, it's giving off radiation, right? That's measured in terms of its half-life. For example, strontium-90, which is a byproduct of nuclear fission, excuse me. So this would be, you'd still have a bunch of strontium-90 over in it's in Ukraine, what is it? Chernobyl, thank you, Chernobyl. Or there'd still be some fallout from old bomb sites, still to this day, right? Not too dangerous depending on how old it is, but you'd still have some strontium-90. Why? Because its half-life is 28.9 years. In other words, if I started out with 10 kilograms of strontium-90, 28.9 years later, I would have 5 kilograms of strontium-90. Half of it would have decayed into its decay particles, uridium and zirconium, right? Which then decay into other particles, which decay into other particles. We have basic physics, right? All right. So eventually they decay into stable particles, in which case they're done decaying because that's what they are. Right? Okay. All right, so write a program that takes the following input. An atomic number, which is always an integer, right? The strontium is 90, right? On the, right? No. What is strontium? Strontium, atomic number. What's its atomic number? Does anybody know? Nobody has it. 38, there we go. So it's 38. Yeah, here, down here I give the example. SR is its atomic symbol, its atomic number is 38. 90 refers to, I believe, its actual atomic weight. Is that right? Because it's an isotope? I'm not sure. Anyway, the element name, the element symbol, the half-life of the element, and then the initial mass in grams, okay? And then what we're gonna do is we're gonna produce a decay table, right? A decay table can be produced like this. So here's the year. So after the first year, what you would do is you would plug that into Y. There's the half-life, which is fixed, 28.9. And then you would raise 0.5 to this power times the mass. So in the first year, right, before we start, we have 10 kilograms of strontium-90. After the first year, it's decayed a little bit into 9.76 grams. We're going to go all the way down until we have less than 50% of the original, right? So that if we have a bomb site or something, and we know that in fact, I was listening to a radio podcast the other day where there's this very interesting problem. They wanted to know how old cells are, right? So in other words, your skin, how old is your skin, right? Well, I'm, some years old, but my skin is not that old, right? My skin is only actually 7 days old because every 7 days, every cell in your entire skin ecosystem or whatever reproduces and replaces old skin cells because, the skin is highly, exposed and it's replaced all the time. Whereas some neurons, you keep them from birth and they never die, or you hope that they never die, right? you have too much to drink and so you've killed some of them at least, right? So anyway, that was a problem that they used this half-life decay model on because, first of all, prior to nuclear testing, there was no way to do this, right? There was no way to do this reliably. But when we had a whole bunch of nuclear bombs go off as part of testing, we polluted our atmosphere with a bunch of radioactive elements. Testing was banned. Air testing was banned in the 60s or 70s or something like that. So we have a fixed time point where there was no more contributing radioactive elements. And so we have a very predictable decay. In fact, we've been measuring it for the last 50 years or whenever the test ban stopped. And so that tells you how old your skin is because all you have to do is measure how much it was, and you have a predictable decay model, and they came up with like 7 days. Other cells, they mapped entire cells throughout your entire body of like your stomach lining. I think that they said that was reproduced every hour or something like that because acid is always killing it, right? Or something. I don't know. Anyway, you'd have to listen to the podcast. But that's an excellent application of this idea. Unfortunately, they pointed out that within the next 20 years, because of the decay model, it will no longer be a reliable measure. So we've got a very small amount of time. They were saying we've got a very small amount of time to use this to our advantage because we don't want to start testing nuclear weapons just to replenish the pollution that we can use to test all this stuff on. Half-lives are not just with radioactive elements, but they're also with, say, chemicals, right? Once you put a chemical into an environment, it eventually does decay or leave, or at least most of them do, and so you can measure their half-life, right? So, idea is good. Let's go with a solution over here. I'm just going to go ahead and go with a class called, well, what should I name this class? Atoms? Probably not all atoms are radioactive. The ones that are radioactive are called isotopes. Should I pluralize it? No, it's one thing, right? Isotope. Right? You don't pluralize structures, do you? Right? Isotope. All right. So what I'm going to do is I'm going to, again, come at this from the idea of computer science 1 where we don't have any object-oriented programming. Public, static, void, main, string, args. I'm going to potentially put everything into main. Maybe I'll look for opportunities to farm these out to other functions or something like that. But I'm not even going to bother with an object yet. All right? What are the things that I need to read in? These things right here. Cut and paste this over here, just as a reminder, right? And I'm going to check that, did they give me 1, 2, 3, 4, don't know what that is. 1, 2, 3, 4, 5 command line arguments. How do we check for command line arguments? If args.length is not equal to the 5 that I expect, system.error.println expected 5 arguments. And you can go into detail on which exact arguments you are expecting, but I won't do that. We'll exit on them. You didn't give me the proper input, I quit. Right. Now let's grab each one of those things. Int atomic number is equal to the first command line argument, args of 0. There. Now, is that going to work? Are command line arguments, are they integers? No, they are strings. So how do I convert that first command line argument over to an integer for the purposes of proper modeling here? Integer.parseInt. Remember, everything is a class or belongs to a class, so it's not just hanging out there. Right? It's inside that class. Following that same pattern, the element name, string element name, is equal to args sub 1. A string is a string. I don't need to convert a string to a string. Right? String element symbol is equal to args sub 2. Right? Half-life would be what? A double, right? 28.9 years, right? I try to give examples that exemplify what you should be doing. So 28.9, not 29. Right? And I don't know if that's all that. I mean, I think it's 28.9 and then change, but whatever. And should I call it H? Double.parse double of args sub 3. Is that a good variable name? No. What does it represent?
Half-life.
Half-life. Right. Can I hyphenate? No, what does that mean? That half minus life. That's subtraction. Nope, it's not going to work. And then mass. I'm also going to make that a double. And I'm going to call it mass immediately. Double.parse double args sub 4. There. All right. All I need to do is keep going year after year until I get to a certain point of mass. In fact, I'm going to rename this initial mass, because that's the mass I start with, 10 kilograms. Then after the first year, there are only 9.76 based on this formula right here. Ooh, based on this formula right here, what should we be doing with that formula? We're documenting it, and we document it because we put it where? Into another function. Public, static, double, I don't know, what should we call it? Foo, for now, right? What does it take? It takes the mass, the year, and then the half-life. Mass, double, or int year, double, half-life. Right? And all I'm going to do is transcribe that formula there, right? So double result is equal to, I think that's why I called it R, remainder, I think it is, mass times 1/2 raised to y divided by h. So mass times 0.5 raised to the power of year divided by half-life. That's my first attempt. Do we have the caret in Java? We do, but it means a bitwise exclusive OR. Is that how I raise powers? No. What should I do instead? Math, library. How do I do a power? Pow. There we go. And it will be 0.5 raised to year divided by half-life. There we go. All right. Do I have integer truncation issue here, by the way? Year is an integer, but half-life is a double, so we're good here. Right? Okay. So return the result. Now we go back and do the most the hardest thing. Remember, cache invalidation. There are only two difficult things: cache invalidation and naming things. What are we doing? I'm computing the amount of mass of an isotope after a certain amount of time. What is that called? It's decaying, right? Decay is also a verb. Let's call it that. Decay. Or amount after decay, or get amount after decay, or something like that. But it's decaying. Okay? All right. So that gives me the new mass. Right? Now I need to produce my table. Do we want a for loop or a while loop? I'm going to produce a table that looks like this. But it's going to keep going until I have less than half of the original initial mass. So what kind of a loop should that be screaming out to you? While the mass is greater than or equal to 50% of the initial mass, I will continue to decay. So I need double mass is equal to initial mass. I'll start out with 10 kilograms, but I'm going to change mass so that it's 9.76, 9 point whatever, until ... Right? Let's go ahead and print this out. System.out.printf %d for the year. Right? I've only got two columns here, the elapsed year and the rest of this stuff. We'll come back and do the header here in a second. But the elapsed year, so I need another variable here, int year, is equal to, I don't know, 0 initially? No. What's going to happen if I've got 0? That's a good question. What happens to that formula when y is 0?
It's gonna turn half into a 1.
The half into a 1, and times mass, that's the first year's mass, right? There we go. So I'll go ahead and start it out at 0, right? And print it out, year, and then mass. And then update it for the next iteration, right? Mass is now equal to, I'm going to decay that amount of mass to year and using that half-life. There we go. I'm updating the mass, now it's less until it gets down to less than 50% of the original mass. Let's test it. Oops, expected 5 arguments. How do I provide command line arguments in Java? Using Eclipse, args, what were the arguments here? Darn it. Strong Team 90, SR. What was the order? Atomic number was 38.
Yeah.
Element name was Strong Team 90. Element symbol would be SR. Half-life was 28.9 years. And then the initial mass was 10 kilograms. Apply that, run.
You didn't increment year?
Stop. Okay. Didn't increment year?
Would you need to do that?
Yep. Year plus plus. Thank you. I actually didn't intend to do that, but you figured it out right away there. There we go. Oh, 0, 1, 2, 3, 4, 5, 6, 7, 8. That's because I'm not printing everything else out. So there's the year, and then we'll tab over, and the mass should be %F, just out to 2 decimal places. Oh, and then end line. Yeah, got to make it look pretty. There we go. So 10 in the initial year. After the first year, we have, 10? 9.76, that matches this, but it's off by 1. All the way down to 5.11, which is the second to last year, the penultimate year. But then the next year, we don't drop down. So I've got some out of order stuff here. Right? I don't know. Increase the year before we decay. Let's try that. There, that looks a lot better. Right? Except that what? Are we reporting that last one? Let's add one more print statement after we're done and we get that. 499. Oh, probably need to, darn it. 8 should be what? What? Yeah, this is wrong because we're decaying way too fast here, aren't we? All right, that means we need to print all this stuff out. Darn it. To make sure that we got it right. I did say 28.9, right? Let's double check my configuration here. Arguments. 28.9, strong TM 90, 10. I don't see an error. Okay, well, at least let's, with 3 minutes left, let's just go ahead and get that header taken care of. Strong TM, so I'm going to copy that as a guide system.out.println or printf. I want the element name, so %s, and then in parentheses %d, %s, and the line, and that's going to be the element name. Oops, element name. Come on, element. All right. Element name, the atomic number, the element symbol. There we go. And then the same thing, but for, I'm just going to hard code this to be elapsed years and amount. I'm going to show you something cool as a last step to this. And then there's my divider. There. All right. Did I misspell this? Atomic number. There we go. Let's make sure that this works, and then I'll show you the thing that's cool. All right. Elapsed years amount. End line. All right. Is that good?
For your divider as well.
Yeah. And that's the thing I'm going to solve by showing you something cool. There we go. That looks a lot better. Strong team 9038, elapsed years, ... We'll fix the rest next time. The cool thing I want to show you, though, is I forgot all those endline characters, right? What I can do is I can make 3 double quotes. So if you want more double quotes, amount, and then go down, and I'm going to format it like this all the way over. Amount, like that, and not like that, and then, nope, stop auto-completing for me. There we go. I'm just going to put it like this. Print. Why are you complaining about that? Oh, uh-oh. Let's check the project setup here. Where's project setup? Properties. Java compiler. 17, no, this should be fine. All right, maybe printf doesn't like it like this, so let's go ahead and go with string header is equal to. Oh, wow. Why are you complaining about this? Am I missing a quote somewhere? Okay.
An extra quote after
Darn it. Anyway, what I'm trying to show you is that in Java, I think 9 or 10 or something like that, they introduced the notion of multi-line strings. If you have 1, 2, 3 double quotes, What you can do is you can put a string, you should be able to put a string literal inside of that and end it with triple quotes here, and then it preserves the string exactly. Like the end line character, I don't have to type that explicitly, but simply because I go down to the next line, it should preserve that in the string. This is called a multi-line string, and it's supported by many languages. This is Java 17. I don't know why it's having a problem with this. I'll figure that out and report back next time, though. Okay. Somebody asked what class this is. This is at UNO, and this is ECEN 194. Just random folks on the internet.